Hello everyone, welcome to today's video on system modeling. This is Dr. Melie, and I'm excited to dive deep into this fundamental concept in software engineering with you. System modeling is the process of developing abstract models of a system, with each model offering a different perspective or view. These models serve multiple purposes. They help us understand system functionality, communicate effectively with stakeholders, and document the design to guide implementation. Modern system modeling primarily relies on graphical notations, especially the Unified Modeling Language, or UML. So let's explore the world of system models together. Before we build any system, we need to understand what already exists and what we're planning to create. Existing system models are used during requirements engineering to clarify the current system's functionality. They help identify strengths and weaknesses, which leads to requirements for the new system. Planned system models, on the other hand, explain proposed requirements to stakeholders and serve as a foundation for design discussions and implementation documentation. In some advanced approaches, like model-driven engineering or MDE, system models can even generate complete or partial system implementations. When modeling systems, we consider four key perspectives. External perspective. This models the system's context or environment. An example would be a context diagram showing the system and external entities like users or other systems. Interaction perspective. This focuses on interaction between the system and its environment, or between system components. Use case diagrams and sequence diagrams fall under this perspective. Structural perspective. This represents the organization of the system or the structure of processed data. Class diagrams and component diagrams are common examples. Behavioral perspective. This shows the dynamic behavior of the system and how it responds to events. State diagrams and activity diagrams illustrate this perspective. Now let's look at the common UML diagram types used in system modeling activity diagrams. These show activities involved in a process or data processing. Use case diagrams. These illustrate interactions between the system and its environment. Sequence diagrams. These depict interactions between actors and system components. Class diagrams. These show object classes and their associations. State diagrams. These demonstrate how the system reacts to internal and external events. It's important to note that the purpose of your model affects how complete or accurate it needs to be. Models used for facilitating discussion can be incomplete or even slightly incorrect, as they're meant to support conversation. Models for documentation should accurately represent the system but don't need to cover every detail. However, if you're using models for system implementation, they must be correct and complete. Let's dive deeper into context models. Their purpose is to illustrate the operational context of a system, essentially showing what lies outside the system's boundaries. System boundaries define what's inside and outside the system. These boundaries influence system requirements and are often a political judgment rather than a technical one. From a process perspective, process models show how the system is used in broader business processes. UML activity diagrams are particularly useful for representing these processes. Moving on to interaction models. These represent interaction between users, systems, and components. Two key techniques here are use case diagrams, which represent discrete tasks involving external interaction, and sequence diagrams, which show the sequence of interactions during a use case. Structural models display the organization of a system in terms of components and their relationships. There are two types: Static models show the structure of the system design, while dynamic models show the organization during execution. The most common example is a class diagram, which displays classes and their relationships in an object-oriented system. Behavioral models represent the dynamic behavior of a system during execution. There are two main types. Data-driven models show sequences of actions in data processing systems. Event-driven models show how systems respond to internal and external events. A classic example would be a state diagram for a system like a microwave oven, showing states such as idle, cooking, and paused. Now, let's explore model-driven engineering, an approach where models, rather than programs, are the principal outputs of the development process. The advantages of MDE include raising the level of abstraction and automating code generation, which reduces adaptation costs. However, there are challenges. Models may not always be suitable for implementation. There are high costs associated with developing platform-specific translators. Let me walk you through some practical examples to solidify these concepts. Context model example. Consider an online shopping system. A context diagram would show interactions with payment gateways, inventory systems, and users. Use case example. For a library management system, a use case diagram might include use cases like borrow book, return book, and search catalog. Sequence diagram example. For the borrow book use case, a sequence diagram would show interactions between the user, library system, and database. Class diagram example. In a banking system, a class diagram would display classes like account, customer, and transaction, showing their attributes, methods, and relationships. State diagram example. For a traffic light system, a state diagram would illustrate states like red, yellow, and green, and the transitions between them. Understanding the differences between model types can help you choose the right one for your needs. Context models focus on the system's environment, while interaction models focus on user and system interactions. Structural models depict system organization, while behavioral models represent dynamic behavior. Use case diagrams provide an overview of interactions, while sequence diagrams detail the sequence of those interactions. Before we wrap up, let's discuss some challenges in adopting these modeling approaches. There's limited availability of comprehensive modeling tools. Customizing tools for specific domains can be costly. Many organizations focus on using models for requirements, engineering, and integration rather than implementation. Also, while MDE emphasizes upfront modeling, agile methods focus on iterative development. However, MDE can complement agile practices if transformations are fully automated. To summarize what we've covered today, models provide abstract views of systems, focusing on context, interactions, structure, and behavior. Context models position the system in its environment. Use case and sequence diagrams describe user-system interactions. Class diagrams define the static structure of a system. Behavioral models describe dynamic behavior. Model-driven engineering automates code generation from models but faces adoption challenges. I hope this overview of system modeling has been helpful. In our next video, we'll dive deeper into creating effective UML diagrams for your projects. Don't forget to like, subscribe, and leave any questions in the comments below. Thanks for watching, and I'll see you in the next one.